Good morning to you all from Pullman in Washington State, USA. I'd like to thank the organisers for the opportunity to present this talk on using the GDV Breeding Information Management System for the efficient management and analysis of breeding data. So as many of you know, GDV stands for the Genome Database for Vaccinium. It is a community database housing curated and integrated publicly available data and analysis tools to enable genomics, genetics, and breeding research for vaccinium crops. In this talk, I'm going to focus on the Breeding Information Management System, which we call BIMS. It can be accessed from the drop-down menu of the Tools section of the top navigation bar. For information on using GDV more generally, please see the GDV presentation given in Technical Session 2 by Jody Hewen, or see our recent webinar series on the GDV presentations. So what is BIMS? BIMS is an online software suite of tools which provides a secure data management solution for breeding programs, while also allowing them to explore and use publicly available breeding data in the host community databases. It is embedded and freely available from GDV and the other crop databases our program developed for rosaceae, citrus, pulses, and cotton. This all comes under the project NRSP 10, which covers crops that have a US annual crop value of production exceeding 23 billion. When designing BIMS, we felt it was critical to give breeders maximal autonomy over their BIMS programs. To that end, functionality in BIMS allows breeders to manage the programs themselves. This includes the ability to create programs, add members, control permission levels, and share data with other breeding programs as needed. It allows them to have the ability to upload and edit accession, phenotype, and genotype data using templates on interfaces provided. Allows them to create their own data fields to store and search data. It allows them to archive the entire data or increments at any time. BIMS is also Fieldbook and BRAPI compliant, so breeders can upload data using BRAPI or the Fieldbook output file. They can create input files using the Fieldbook app, and where the breeding program data is collected on different devices, as is often the case, the data can be directly synced using BIMS. BIMS also has various search and analysis features. These currently include the ability to perform and view statistical analysis on any list of accessions, and to search across various categories and trait cutoff values, and then save the resulting lists and phenotype data, and also to search genotype using accession or marker properties. In addition to the functionality just described, there are more advantages to using BIMS. So for example, for collaborative projects, all or part of the data can be easily released to the public when the project ends, which allows the data to be reusable and to satisfy federal granting requirements. Also, data is backed up nightly, both on and off-site, so this protects the valuable breeding program data. We recently had a case of a breeder who lost a great deal of their breeding program data due to a major systems error at their university. Fortunately, they were able to download that data from their BIMS account. In addition, we provide significant training and support. The GDV team, which consists of the the BIMS developer, the BIMS designer, and the GDV database manager. And this can include support to help you get your archival data into BIMS. One last advantage I'd like to tell you about for using BIMS is that it's built in Triple, which is an open source toolkit for database construction that is currently being used by over 100 databases worldwide. In addition to the core modules, users worldwide are developing and sharing plugin extension modules, which are currently over 40. This includes BIMS. And BIMS then can be used to any Triple database. It just needs to be inputted. The Triple developer community are well organized and collaborative, and it makes it easy to provide input on new tools. And why this is particularly important that it's built in this Triple system is that this is a resource-efficient way to build databases. And it created this whole wider community of developers, and this makes it a much more sustainable system. And here you can see we have the website here for the Triple. It tells you all about the Triple toolkit. So now I'm going to show you a short demonstration of BIMS, and it will cover many of the features of BIMS. From the home interface of BIMS, there are three main areas. First, there is the header region, which displays the selected crop and breeding program. Here it allows breeders to change the crop or program, has links to the configuration page, account page, and the home page of GDV. The second part of the interface is the accordion menu on the left. The menu allows users to switch between the various sections of BIMS. The last region is the tab region, and this is where the users primarily interact with BIMS. Each tab in BIMS has an instruction section that can be expanded by clicking on it. The instruction page provides information on how to use that tab. Without logging in, the public users can't use a crop in a public BIMS program to view data and explore BIMS, but they don't have access to any of the private breeding data. The About BIMS and Help menus provide various information, including links to the BIMS manual and mailing list. To import data into BIMS, the data needs to be in the BIMS templates that are available to download in the template list under the data import section on the accordion menu. A table of the templates pops up with the hyperlinks to view and download the templates. Readers can also download all the templates as a single Excel file. Once the data has been entered into the template, users can load the data using the Upload Data link. In the Upload Data tab, the file name will appear in the uploaded file sections after a file has been submitted, and then you can view the progress of it by clicking on that link. Phenotype data can also be imported to BIMS using exported files from Fieldbook. The Manage Breeding section on the right side lets users view, create, or edit data for trait location, cross, accession, and trial in addition to the program. If a user selects trait under Manage Breeding, the trait section opens on the main page. Here, users can see all the trait descriptors in the trait section. When there is imported public phenotype data, the descriptor groups of both public data and private data are displayed and can be used to view, search, and analyze the phenotype data of the combined data set. Once a trait descriptor is selected, in this case, fruit length, the details for the trait descriptor, along with the distribution of the trait values and statistical summary of the full data set, will be loaded to the BIMS results section, and this search can be saved or downloaded. In the search selection, users can search data by phenotype, cross, or genotype. If phenotype is selected, then the search has three sections. The first one is where the user chooses the property type, traits, or custom properties, if they have them. In the second section, this is where the filter is set, and the results of the selected filter then show in the third section. So say, for example, we choose trial and set the filter date to be 2011 and 2012. Then hit the Add button at the bottom right-hand section, then more filters can be added. In this example, fruit length in traits, and then the distribution, as you can see, shows up here. The minimum maximum values can be changed and added, and the number of phenotype data points will show on the right section. Further filtering can be added until the data set is refined to the desired result. If you don't like certain filters, you can simply remove them, as you can see here. If you are satisfied with the results, you can view them or do further analysis on them. If you have selected the View option, you will see the accessions from the initial filtering here. They will only show you the phenotypes that you selected, which in this case was fruit length. You can add more options to that phenotype. You go up to the column options for phenotype and select more properties to be added, to be displayed. So here you can see other properties that can be added in this particular example. And then you can see that if you've selected them, you can see they've been added here to the table. You can download the data in two different forms, wide form and long form, and you can add the statistics to be able to be downloaded as well. And you can also save the search. You can also analyze the data. So if you recall in the search results, you could choose to view the results as you have just seen, but there was also an Analyze button that you could use to analyze the data on the refined filtered data. You can also go to the Data Analysis section on the right accordion menu. So in this example, data year was selected as a category, and the years 2011, 12, and 10 were selected. Clicking on the Compare button will then populate the statistics window, and you can see the distribution for each year with the statistics in a table below. If you want to remove one of the years, you can just select the year at the top and it will be removed from the statistics window. Customization is one of the very important and unique features of BIMS. In addition to being able to add new traits at any time, BIMS offers various ways to customize the data management. And so while I'm not going to go into it in this example, you can see here the types of data that you can edit and the customization you can make. One of the newest functionalities in BIMS is that we've just made it BRAPI compliant. What this means is you can import data in the Fieldbook app to BIMS just by clicking a button. First, you open the Fieldbook app in your device, then you connect it to BIMS and receive an empty input file for the trial you chose. Second, you collect phenotype data using the Fieldbook app. And then third, you export the phenotype data to BIMS by clicking on BRAPI. Then you can go into BIMS and you can check that the data was uploaded correctly. Coming soon in BIMS is the ability to manage image data. So you can input image data through templates or add them for your device as a phenotype data, which you can then search, view, and download. This has just been tested on our development server and should be available very soon in our live server. So in terms of future development of BIMS, we are creating a standalone BIMS, which will be located at breedwithbims.org for breeders who don't have access to community databases. And this is at the request of these, what we call orphan crops. We also have a suite of things we want to do as part of the NRSP 10. We're going to add support for phenomics data. We're going to add GWAS analysis capability. We're going to add global performance prediction capability. We're doing that right now in collaboration with a colleague in Australia. And then we're going to add further analysis tools and breeding decision tools as requested by the community. And then the last thing we're doing as part of that project is identifying sustainability models for the NRSP 10 databases, which of course include BIMS within those. To learn more about BIMS, please go to breedwithbims.org. You can follow us on Twitter, join our mailing list for updates, etc. Last week, we were pleased to report our BIMS manuscript was published in the Database Journal, and of course, it's open access. If you have any questions for us or a follow-up to the symposium, please contact us via the contact form on Breed with BIMS and let us know what you think about this BIMS software. Lastly, we'd like to thank all our partners in this effort, funding from USD and IFA and all the land-grant universities that gave up some of their Hatch funds to fund NRSP 10 for the last 10 years. NSF, the USD SCRI, BACCAP project, and Washington State University and NC State for supporting this project. A huge thanks to all the community support for this project, the Triple Community, Ag Biodatabase Consortium, GMOD, BRAPI, and of course, the Vaccinium scientists and industry. Thank you for your attention.